Welcome, my dear student, to the new series of basic electrical engineering. जैसे कि हमने ऑलरेडी दो थियोरेटिकल क्वेश्चन से या कुछ बेसिक न्यूमेरिकल्स से यूनिट नंबर 1 के जो ऑलरेडी हमने क्लास में लेक्चर्स में किए, बट उसके साथ साथ उसके अलावा आपको और न्यूमेरिकल्स की मैक्सिमम प्रैक्टिस की जरूरत है। तो उस प्रैक्टिस ओरिएंटेड ही मैंने ये जो वीडियोस की सीरीज है जो आपके सामने मैं शेयर करने वाला हूँ, ये उसी लिए उसके लिए मैंने आपको ये न्यूमेरिकल्स में आपके सामने प्रेजेंट करा। So let me start the complete series. First of all, I request all, please everyone, go through each and every videos of a numerical, because all that numericals are very much important for your university examinations. You go through each and every numericals. If in case any doubt, if in case any queries, contact me or you can ask. Okay. So without wasting so much time, let us start our the numericals. As we have to discuss the basic electrical engineering unit number numericals. Let me start the numericals. First numerical will be in front of you. Determine the resistance of a 20-meter copper wire of 2 mm in diameter. With the specific resistance of a copper is of 1.72 into 10 to the power minus 8 ohm per meter. Now, each and every time when I taught the numericals, I repeatedly told to each and every one that whenever you have a numericals, whenever you try to solve the numerical, first read the numerical up to 2 times. The reason is that whenever you are reading the numerical 2 times, then and only then you got what exactly the given things and what exactly you have to find it. Okay. So for that purpose, the very important thing is that you have to be you have to go through the numerical very efficiently, very accurately. Okay. So here, as per the numericals, the numerical is that determines the resistance of the 20 meters of copper wire with 2 mm in diameter with a specific resistance of the copper wire. As per that, it is given as that the given terms are the first length. The length of copper wire is of 20 meters is given. Along with that, the diameter of the is given. But diameter here the given is in terms of millimeter. So it is converted to into 10 to the power minus 3 as to the scale of a length. Along with that, the resistance of a copper wire is given. So here the resistance of the copper wire is given. And whatever we have to find out, we have to find the value of resistance. Whenever there is a question is that find the value of resistance, this is the basic numericals. So here we have to use a formula that R is equals to rho L by A, or R is equals to rho L by A. So for that purpose, first we find out the cross sectional area. सबसे पहले हमने cross sectional area find out कर लिया by the formula pi d square by 4. So here I know the diameter. So as for that, I just put here the diameter square, pi into diameter square upon 4. So you got the cross sectional area. Because in terms of the formula of resistance, rho L by I, where resistivity into length upon area. So I just put this value and you get an answer. So the resistance of this copper wire is 0.109 ohm. So here the important formula is this one. यहाँ पे ये सबसे important formula है. If you put it properly, if you put each and every terms properly, you get definitely answer. So this is the smallest numerical that will be in front of you. I hope you understand it. And in case you does not get it, then please clarify it. Okay, thank you. So we will move toward the next numerical. The next numerical will be in front of you. Calculate the resistance of the 100-meter length of wire, which having a uniform cross-sectional area of 0.1 mm square and having the resistivity of a 50 micro ohm centimeter. We have to calculate the resistance if the wire is drawn out from 3 times of the original length. Now the numerical was simple but quite much tricky. The reason is that there is some area is given, there is a resistivity is given, along with that length is given, and we have to find the resistance, but resistance of a new resistance while changing its value. So initially what we do, we will find the resistance of the given जो दी हुई टर्म है, उस टर्म के हिसाब से हमने रेजिस्टेंस निकाल लिया जो कि आ रहा नियर अबाउट 5000 ओम. Okay, according to you. Then after that, what it say? They will show that the new resistance will be changing. The new resistance will be have 3 times length. Length is of 3 times. So due to because of that, the new cross sectional area will be of the A by 3. So the volume of a wire will be remains same. So as per that, the new resistance will be given as R dash. Also original resistance given as R. The new resistance is R dash is equal to Resistivity will also change. Make kind of change होगा. Change will be in terms of length and change will be in terms of area. So change in length upon change in area will be put here, and as per that we get an actual resistance which is 45,000. Actually, the resistance will get increased here in terms of the new resistance. So the numerical was simple. The numerical was same as the previous one, but one extra term will be added here, that the after changing the length or after changing the area, what exactly the change will happen in terms of the resistance, that here we have to find it. Okay, so I hope you understand it. Let me move for another numerical. Find the resistance of a coil of mean diameter of 2.5 meter containing of 100 tons of a magnetite wire of 0.0645 centimeter in diameter. The resistivity of magnetite is 4.2 into 10 to the power minus 6 ohm per meter. And now, as per the numericals, there are some given data. In that given data, whatever whatsoever you have to try to find that diameter is given, that is 2.5 meter. Then the number of turns is given. Then resistivity is given. Why do we find out? Where to find out the resistance? Now, before going to that one, first we try to calculate the circumference of the turn of coil by using formula pi d. After finding the circumferences, here the number of turns is given. Right? We does not get the direct length is not given in of the coil. So for that purpose, I will here the length of a coil is given as number of turns into circumference. जितना circumference हमने calculate किया है, उस circumference को multiply करेंगे जितने number of turns है. Total number of turns are 100. So 100 into 7854. So the length of a coil is 785.4. Now as per that, the cross section area is will be pi d square by 4. So here I just put the values of a cross section area, the pi d square upon 4, and after that we get a value of a cross section area. Then at the last we just use a simple formula of the resistance is equals to rho L by A, and here I put the value of resistivity, here I put the value of length, and here I put the value of area. As per that we get a value of the resistance of that particular wire. Okay, so in that way, here the new thing is that here directly length is not given. डायरेक्टली लेंथ दी नहीं थी अपने को, कुछ अभी नंबर ऑफ टर्न्स दिए थे, उसके बाद डायमीटर किया था. उस डायमीटर से सबसे पहले हमने सर्कमफ्रेंस निकाला. उस सर्कमफ्रेंस को हमने नंबर ऑफ टर्न्स के साथ मल्टीप्लाई किया, तब हमको मिली लेंथ, और उस लेंथ से हमने फाइंड आउट किया क्रॉस सेक्शनल एरिया. तो ये फ्लो आपको समझ में आना चाहिए. दैट फ्लो वाज प्लेइंग अ वेरी इंपॉर्टेंट रोल व्हाइल सॉल्विंग दिस टाइप्स ऑफ थ्योरी. ओके, so otherwise the numericals are to be same, the formula are to be same. We have to just get the value and put the answer. Put the value and get answer. So by that we can easily solve any numerical. But important thing is that we try to examine, or we try to understand the way or the sequence to solve the numerical. Okay, that was like a very important. So I hope you understand it. We will move for the next numerical. A coil is made up of a copper wire of 1 mm in diameter. 1 kilometer in length is connected to the parallel with another coil of aluminum wire of 1 mm in diameter. The resistance of a combination of 9.738 ohm if the resistivity of a copper wire is 1.72 into 10 to the power minus 8 ohm per meter, while that the aluminum is 2.8 into 10 to the power minus 8 ohm meter. What will be the length of aluminum wire? Now, as for that, first we write out the given term, whatsoever the data which is to be given here. Here, the diameter of copper and aluminum wire will be given of 1 mm. Then the length of copper wire is given by LC. Then the resistivity of copper wire is given. The resistivity of aluminum wire is given, and the length of aluminum wire will be equivalent. Will be given. Whatever we have to find out, we have to find the length of aluminum wire. R equivalent resistance also is to be given. So what I do here, I just first find the value of area for the copper. Now for to find area of a copper, or to find area, because we know that the area of a copper wire and area of aluminum wire both are same. So for that purpose, we just use the formula that pi d c square upon 4. From that, we get a value of the area of both for aluminum as well as for copper. Now, after getting the area of all the copper and aluminum, we just find the value of the resistance of a copper. So for that purpose, I use for RC is equals to PC into LC by A, where rho C means resistivity of copper, LC means the length of copper, AC means area of a copper. So I just put the value here, and from that we get a value of resistance resistance of the copper wire. Okay. Now after getting the resistance R equivalent, 1 by R equivalent equals to 1 by R means 1 upon R equivalent, 1 upon R aluminum plus 1 upon R copper. So here I put this value. From that we get an RA. It is the resistance of the aluminum wire. Now again, after getting the resistance of the aluminum wire, I just put this formula here, that resistance of aluminum wire, resistivity of aluminum, area of aluminum, and length of aluminum. Now, as per this formula, there are four quantities. Among that four quantity, we know that the resistance, here we already find out. We know that the resistivity that we given. We know that the area that we will also find. Now remaining thing is that LA. That is we have to find out. जो अपने को निकालना है. So here I use the formula that LA is equals to RA into AA upon PA. So here we got the length of that aluminum wire that we have to find out in the numerical. जो अपने को numerical में निकालना है. I hope you also understand this numerical because it was very simple. Okay, so we will move to the next numerical. This was quite much different as usually. An electric iron which is rated of 750 watt is operated for the 2 hours per day, and a washing machine having a rated of 400 watt is operated for 1 hour per day. And if the cost of a unit of is rupees 6 per kilowatt per hour, then find the cost of energy used operate for electric iron and washing machine for 30 days. Now here the given data is that number of days is given in 30 days. Cost will be given as 6 per kilowatt per hour. इलेक्ट्रिक फैन को पावर चाहिए 750 वाट और वॉशिंग मशीन को पावर चाहिए 400 वाट. और जो इलेक्ट्रिक फैन आयन है वो 2 घंटे डेली चलता है और वॉशिंग मशीन है 1 तास 1 घंटा बचता है. So first we all will calculate the energy consumed that will be using for power rating into time operation. कितना पावर लगता है और कितने घंटे चलाना है कितने दिन तक, वो सभी कैलकुलेशन यानी एनर्जी कंज्यूम. तो हियर वी फर्स्ट फाइंड आउट एनर्जी कंज्यूम बाय इलेक्ट्रिक आयरन. अपने को पता था कि भाई 750 वाट लगता है और इसको 2 घंटे 30 दिन तक चलाना है. तो टोटल एनर्जी कंज्यूम बाय इलेक्ट्रिक आयरन इज 45,000 वाट पर आवर. बट जो अपने को कॉस्ट दिया है वो किलोवाट पर आवर के हिसाब से है. So first I just converted that watt per hour into kilowatt per hour. So we got it at 45 kilowatt per hour. Similarly, we find then we find the cost of energy of electric iron. The electric iron required 270 rupees. That 45 into 6. Then energy consumed by similar washing machine is 400 watt. उसको पावर लगती है 1 घंटे 30 दिन तक चलाना है. टोटल 12,000 watt per hour लगेगा. तो उसको भी कन्वर्ट कर दिया इन टर्म्स ऑफ 12 किलोवाट per hour. And the cost of energy required for washing machine is 12 into 6, that is 72. Now after doing this calculation, we get the overall cost of the energy for the washing machine. So this amount of energy, this amount of the cost will be required for to drive the electric iron as well as for drive the washing machine. So in this, these are the basic simple numericals that you can solve on the basis of the formula of resistivity, resistance, length, and area, and all. So I hope you understand all these 4 to 5 numericals. In case if you have any issues, you can ask me. Thank you. Thank you very much.